Mr. T here with a tutorial on trigonometry, and today we're going to be exploring the graphs of the sine and cosine function. So we're going to be looking at this function here. In our function here, our input variable, you could think of it as the x here, so our x-axis here is going to be theta, and this is our value of the thing. And we're going to be graphing and plotting that. And so remember, on the unit circle, as we go around the circle, theta is increasing. And for any given angle of theta, the way we would calculate the sine value for using the unit circle is the opposite side of this triangle. Remember, this is a unit circle, so this is 1. So the opposite side here is our sine of theta. It's also the y-coordinate of the points here as we go around. So remember, these y values will be the values of the sine. So we're just going to march around the circle here. So at 0 degrees, we have a y value of 0. Now I'm going to do this in radians. Normally when we graph these sine functions, we're using radians. So let's kind of jump ahead here to pi over 2. So on the graph, that would be this point here, pi, half of pi. Our y value is 1. And then if we jump over to here at pi, our y value is 0. And when we come down here to 3/2 pi, we are at -1. And back around to 2 pi, we're at 0. Now remember, we could keep going. So this would be, if we're counting by halves, this is 1/2, 2/2, 3/2, 4/2. So 5/2 pi, or 2.5 pi, we're back here at 1. So if we go another half of a pi here, we're at 1. And then at 3 pi, we're back here at 0. And you can see that our pattern, since we're going around the circle and using the same y values, we're going to keep going up, down, etc. Now let's try to fine-tune this shape here. Is that a straight, like a sawtooth here, or what does it look like? So let's go halfway. This would be here. So this was pi over 2, remember? And if we go half of that, we're at pi over 4. So we're right here. So we're at square root of 2 over 2, which is approximately 0.707, so about 0.71. So let's go. I counted here, each of these is 0.25, so that's 0.5. This would be 0.75, so we're about here. If we go 1/3 of the way to pi over 2, we're at 1/2. So if we go 1/3 of this way, go 1/3 of that part, we're at 1/2. And at 2/3, we're at square root of 3 over 2, which is about 0.87 or about 0.9, so we're almost up here at the top. So you can see there's a little bend to this, so if we trace this, we've got a little bit of a bend there. Going around, we're going to be symmetrical, so we're going to have a point here, a point here at halfway in our quadrant. We're going to be here, and then we're back here. So this doesn't have a sharp point. It kind of smoothly goes over and comes down. And we could keep plotting points, but I don't want to belabor this. This is going to come down and loop up. It's hard to draw with my tablet here to get these points, sorry. I'm not hitting them more accurately. And we could also go backwards around the circle, so at negative pi over 2, we would be at -1. We'd be back here at 0, back here, down. So we have this shape. Now this is an example of what's called a periodic function. Because it keeps repeating the same pattern. And the sine curve, if we started here, goes up, down, and then back at 2 pi. That length here is one period of our oops, that's it. Sorry. Here. 1 period of our sine function. So the period is 2 pi. It also repeats up and down. So it has a total height going from our max to our min of 2 units, and this height going from what I would sort of call our midline here, our baseline, at the maximum is 1, and that is referred to as the amplitude of our function. So the sine function repeats in both directions forever, and every 2 pi units we get the same pattern, and it keeps going, oscillating up between positive 1 and negative 1. So just to summarize, the sine function has a period of 2 pi. The amplitude, which can be found by half the total distance from the maximum point to the minimum point, is 1. And for the pattern that we have here, let's go back. If I call this 0, so we've got 0, high, 0, low, 0. And we would be back to high, 0, low, 0. So we kind of have each pattern is oh, ho, low. And this distance for each of these parts of our pattern, I'm going to be calling our increment, and it was 1/4 of the period. So that's what I'm referring here. We're going to divide each period into fourths, which I'll be calling increment, and for the sine function we have this pattern: 0, high, 0, low, 0. Later we'll explore the cosine function. Now sometimes the sine function, instead of just having the basic sine function, we will have we may want to multiply that by some number. So I've got some examples here, and we're going to explore those graphs with the graphing calculator here. Now I've set up my screen, so let's just look at the sine curve here. Oops, I press graph, sorry. Now I've got this set up where going out to here is 4 pi. So we're going between 0 and 4 pi here, and back to negative 2 pi. So we've got, for the sine function, since the period is 2 pi, we've got three repeating patterns here. So now let's see what happens if we multiply the sine by some number. So let's start with 2 times that. So let me add another function so we can see what it does here. So we've got 2 sine of theta, or x, and let's graph that. So we can look at it. We can see here that the period didn't change. We still have a pattern between 0 and 2 pi. So 0 and 2 pi, we have one pattern, so we have the same number of patterns. But what happened is our amplitude increased, and it increased to 2. So this changed the amplitude to equal 2. And let's look at 3. So let's change this to 3. This time we can see the amplitude went up to 1, 2, 3 units. So here our amplitude was 3. And again, there was no impact on the period. As you can imagine, if we did 4 here, it would go up to 4. Now let's see what happens if we put a negative number in here. So let's change this just to minus or -1 and see what happens. So this again is our base function, the sine of x, and this is our negative sine of x. So what happened? As you can see, it flipped it. Where we used to go high, we now go low. So where we used to go high, we go low. So we went O, high, O, low, O. And now we go O, low. And our amplitude is still 1. So a being -1 flipped our pattern. And let's just do one more. Let's say this had been -2. see that if we put a -2 there, it's still going to flip the pattern, but now our amplitude is higher. So the A value affects the amplitude, and if it's negative, it flips the pattern. Flips there, I think flips probably only has one P, sorry. Now let's look at what happens if we now multiply our angle by some number. So inside the parentheses next to our angle, our x or our theta, we have a number. So let's go back and graph our base function, and let's change this now to the sine of 2x. So again, here's our base function, so let's watch that and let's see what happens. This is our with the 2x. Now you can see the amplitude stayed the same, but it's repeating much faster. So remember, from here to here was 2 pi, so once before we had one pattern in 2 pi. Here we have two patterns in the same interval. So this number here doubled the frequency. So it doubled the frequency, or how many times the pattern repeats. It also changed our period to be pi. 3 is going to be a little hard to see. Let's look at 4. So let's change this to 4. Remember, this is 2 pi here. 1, 2, 3, 4. So we got 4 of those patterns. So now our frequency was 4. And our period is pi over 2. We can see that if we change our x scale here, say to go to out to say 1 pi. So let's change our maximum value to be 1 pi. So out here we've got 1 pi, and we get 2 whole patterns. So this is pi over 2. So between pi over 2 we got a pattern. And let's look at our last example. What if this would also be equivalent to theta over 2. So what if we take a fraction in here? And let me put the window back here to, let's go out here to 4 pi. So since this is 4 pi, remember we get 2 patterns normally. But now out to 4 pi we only get 1 pattern. So it halved our frequency. So now our frequency, meaning the number of patterns in 2 pi, is now a half, or our period is now 4 pi. So B here didn't affect the amplitude, it affects our period, and the new period is going to be 2 pi divided by B. So in this case 2 pi divided by 2 was 1 pi. Here 2 pi divided by 4 was pi over 2, and here if we took 2 pi divided by a half, we would get 4 pi. Now frequently we're going to be putting those two things together, so let's sketch a graph here. So we've got A in this example is 3, so that implies our amplitude equals 3. And our pattern, since that's positive, will be the oholo. And B is 2, so that implies our period is 2 pi over 2, which is pi. And this thing I call the increment, that's how the distance between each of these changes here, is going to be the period divided by 4, or pi over 4. What I mean by that, so since this is pi over 4, so when we go each point on this thing, each tick marks pi over 4, we'll go one part of the pattern. So here, let's just put a little guide on here for our amplitude. So our amplitude is going to be 3, so let's put a little line up here to remind us of how high and low we're going to go. So in our pattern, this is our high, this is our O, and this is our L. And we're starting here. Well, let me just do that in red so we can see. So we're at O. Now this is one increment, pi over 4. That's our increment here. And we're going to go to high. Then here we're O, low, O. So we've got one pattern here. I'll see if I can sketch it. I'm having trouble today with my drawing with this pad. So you can see here we completed one pattern in pi units, which was our period, and we could keep going every tick mark. Sometimes they're going to ask us to graph between 0 and 2 pi. Sometimes it may 2 patterns. Sometimes it may ask you to graph it, say, between negative 2 pi and 1 pi. So if we went backwards, we just do the pattern in reverse because we're going backwards. I messed up here. That doesn't go there. That dot's here. So let me see if I can fairly quickly try to sketch this in, but not have it be a total mess. I messed up there. And again, this continues forever, and this continues forever. So fairly easy. We were able to sketch just by knowing the shape of our sine curve and the impact of our A and our B. Now let's look at another example. We'll try to do this one a little quicker. So here our amplitude equals 2, the absolute value of that, and since it's negative, we're going to flip our pattern. So we're going to be O low, O H O, and our period is going to be 2 pi over B, which is 4 pi. So this time our increment is going to be 1 pi, 4 pi over 4, or pi. And remember, we're going up here at 2 on our amplitude at the high, and we're at negative 2 for our low. And let me do this in another color here. Let's use green. So we're going, every increment is pi, so this is one increment. So here we're at O. Now we're doing flips, so we're going low, and then we're going back here. Going backwards, we're going high and low. So if we were just sketching it between 0 and 2 pi, we're getting only a half of our period shown here. So between total here, we've got 4 pi, so we've got one period between 4 pi, which we said. Let's wrap up here a little bit talking about the cosine. Now here we're still going to be having our theta, but now we're talking about cosine. So remember, cosine is the x-coordinate. So this is the cosine. So if you think about it, we're looking at the distance horizontally. So it's a little confusing because we've got the letter y here, but we're looking at x-coordinates. That's because on the unit circle, the cosine is the x-coordinate. So let's kind of do the same thing we did. Let's hit the pi over 2 units. So at 0, we're up at 1. At pi over 2, we're at 0. At pi, we are at -1. And at 3 pi over 2, we're back at 0. And at 2 pi, we're back to 1. And you might imagine, since these numbers go in a circle, that the pattern repeats. And take my word for it, but since the numbers that we have here are the same numbers at the same interval, just going backwards, the shape of the curve is going to be the same. So here we've got oops, my hand's slipping on the little bit pad that I have here, the tablet for drawing. Now, if we didn't have labels in x-axis, we couldn't tell the difference of whether this was a sine or a cosine, but the difference is where it starts. So our pattern for the cosine is high, O, low. So like hello, hello. So this is our cosine. And I'm not going to go through it, but the A and the B do the exact same thing. So on these functions, A affects the amplitude. So if you take the absolute value of A, we get our amplitude. The B affects the period, and in fact our period of our function is 2 pi divided by B. And to use our patterns for sine or cosine, we divide the period up into what I call an increment. We divide the period up into fourths, and every one of those increments we change letters here. And if A is positive, we have this pattern, and we flip the pattern if it's negative. So these are the notes for the sine. You can pause the video and record that if you need. And here are the notes for the cosine. It's exactly the same. The only thing different is our pattern. So I'm not going to sketch, the video's getting long here, I'm not going to sketch, say, something like y equals 3 cosine of 2 theta, because it would be the same as we did with the sine. Our amplitude would be 3. Our period would be 2 pi over b, which is 2 with pi. We would update our pattern on an increment of pi over 4, the period over 4. And the only difference would be when we lay out our points, we would start high, go to 0, go low, 0, high. Everything else would be the same. So good luck with sketching your graphs, and we'll be talking to you around town.